All right, everyone. Uh, I'll start off by apologizing for last week. I normally do not miss class unless I really cannot physically make it. And last week, I just physically couldn't do it. So I don't know what I got. It wasn't the flu. It wasn't strep throat. It was something weird. And I lost my voice completely. And it was just strange. And I don't know if I've told you all this. My wife's a PA. Have I told you all that? She's almost a PA. She's almost done. She's doing clinical rotations and stuff. And I don't know what your doctor's like, but my doctor doesn't want to ever give me antibiotics ever. Who has a doctor like that just won't ever give you antibiotics, right? And supposedly it's the right thing. You're not supposed to just like pump people full of antibiotics because they build up a resistance for it and all whatever. But I grew up. My doctor like had antibiotics like I kid around like in candy jars out in the waiting room. You know, it's just like amoxicillin, penicillin, whatever. I mean that's not really what it was, but I mean they just you come in and you're like, hey, I strained my leg. Like, take some antibiotics. We're gonna give you some antibiotics. So that's all they ever gave you. So all I wanted was some antibiotics, and I finally got some, and now I feel great. So, I don't know. I keep telling my wife she needs to get her, face out of the books and get to the real world situations, like, you know what I'm saying? Give me some antibiotics. Give me drugs. All right.
What's the difference between a PA and an RN?
RN? Oh man, I don't know.
They kind of the same thing?
They're both what are called mid levels. So it's you have the doctor, then you have the mid level, then you have like the techs. Yeah, so they're like they're equivalent, but they do different things. That's true too. A PA can write a prescription. Yeah, so yeah. All right, but there's a lot of things I don't know about that, so I can't really speak to it. All right, so that's the first thing. Now I did ask you to come in, and I had a sign put on the door or something to please check your email, and I'd given you a take-home, basically a set of review problems that went over the stuff that we've done. I said I was going to take that as 2 quiz grades. So first, any questions over any of the problems? Anything that you'd like for me to look at or to demonstrate? No? We're good? What I'd like to do then, if you don't have any questions. Okay. Yeah, if you didn't check your email, you didn't know. But here's the deal. If you have it today to turn in, I'd like to collect it. I'm going to try and give it back to you today or next time. If you don't have it today, you can still turn it in next class. You won't get the full credit, but you'll get credit, okay? You want to keep it there? Then just after class, let me just check it off there, okay? Anyone else, then just please turn it in, and I'll get it back to you so you can review it, unless you want to keep it in your binder. Did anyone do it? Yes? Okay. All right. Well, I'm just curious because this is my class before y'all. This is everyone that did theirs, and I'm like, this is all I have for you? Like 2 people? 3 people? That's it? Yep. Okay. Yeah, here, just throw it right here for now. Anyone else? You can just set it right there. Okay. All right. Now, while people are kind of dropping that stuff there, I will talk about what we're going to do today. Today we are going to do 5.6 in the book. And then on Thursday, we will cover .4. We're going to jump to a different chapter. You'll see why once we do it. Then next Tuesday, we're going to do a review for the test. Next Thursday, we're going to take the test. We're going to have exam 2. Now, if you look at the schedule that I had printed online, we were supposed to have exam 2 next Tuesday, but I'm pushing it back one day, all right? That's probably a good thing because it's, the last day before spring break. Can y'all believe spring break's already here? I don't know why, but, when I was, it's all right. I'll keep it together. When I was in school, it seemed like spring break, it was hot. It was, you go to the beach, it was fun. It seems like every spring break the last few years has always been like still kind of cold out. It's weird, right? You still go to the beach, I know, right? You numb yourself from the cold, don't you? In other ways. All right. Well, so it's like a couple of weeks away, right? We have this week, next week, then spring break. So I think if we had the test on Tuesday and then came in on Thursday, I think first of all, not many people would show up. But then if you did, you're not going to remember anything I said after spring break, right? You come back, hopefully you'll just remember how to get back to Northwest Vista College after spring break, right? So that's our plan. Got it? Okay. Let's start with 5.6. This section is actually, this is a really good section, 5.6, as far as bringing all of these concepts from this chapter together into like one problem, where you have just a single problem that requires all the different types of skills that we've talked about in this chapter. All right, here we go. Anyone have any questions? 5.6, polynomial division. If you did that review assignment that I, asked you to do, we have 3 operations we've talked about. We know how to add and subtract polynomials. That's where you just look at the coefficients, the numbers, you put them together. You don't mess with the powers. And then you have multiplication of polynomials, and that's where you do mess with the powers. And we did last class, it was like monomial times monomial. It was monomial times binomial. Remember all that? Monomial, trinomial, binomial, trinomial, binomial, binomial. All those different combinations. Well, we have not talked about division, and it turns out division is the most difficult out of all of the different operations. Now, we're going to break this class into 2 separate categories, I guess. We're going to have the easy case, and we're going to have the hard case. The easy case is when you have what I'm about to show you. It's monomial division, when you divide something, a polynomial, by a monomial. So here we go. Dividing a polynomial, I'm just going to say poly, okay, by a monomial. And next to this, I'll put easy case. So if you're looking at a division problem on the test, and I ask you to take a polynomial and divide it by a monomial, you should know that this is going to be the easy sort of way of dividing. You should be happy to see this. Here's your first example. And I think I'll just take some problems out of the book here. Okay, let's do 16 x cubed y minus 8 xy squared over 6xy cubed. We need to first recognize that we do have division, right? Everyone okay with the fact that we have division here? And what we have in the denominator is a monomial, right? A single term. What do we have in the numerator? Two terms? Binomial, right? We have a binomial on top. We have a monomial on bottom. We're trying to divide the monomial into the binomial. So the way this will work is as follows, and this only works again if we have a monomial on the bottom, right? Have to have this. All we need to do is split this into two separate fractions. So I take the first term in the numerator, 16x cubed y, and I divide it by that denominator, 6xy cubed. Then I'm going to put plus, and I'm always going to put plus. And then I'm just going to grab the next term, which is negative 8xy squared, and I'm going to divide it by the 6xy cubed. Why do you think it is that I can do that? I mean, does it seem reasonable that that's fair, that's a legal move? Yes. You could do the minus if you wanted. You could make this a minus and put a positive 8 here. But we're going to be doing problems that have like maybe 2 terms in the top, or maybe 3, or maybe 4, or maybe 5. I always just tell everyone, just put a bunch of pluses, and then whatever the sign is here, just put it up there. You can do the minus here. Just be careful not to do the minus twice, or be careful not to forget the minus. Why do you think we can do this? Look back at fractions. If I asked you to do 1/2 plus 5/2, could you do that? If I asked you to add these two fractions together? They have the same denominator, right? So what you would do is you would put the numerators together, 1 plus 5, and then over 2, wouldn't you? Well, that's kind of like what we had here. We had 2 things over 1 thing, right? 2 things over 1 thing, and then we split it apart into 2 pieces again. So we actually took the addition and we took it backwards 1 step. Do y'all see that? And now by doing that, what we can do is we can work on each one of these by themselves individually. So let's go ahead and take a look at this. I'm going to highlight something here. X cubed is on top of x, right? What's x cubed over x? So remember this rule? I'll write the rule out to the side. What's x to the n divided by x to the m? It's subtraction, right? N minus m. Remember that property? So this is x to the 3 over x to what power? 1, right? So that's x to the 3 minus 1? X squared. And where will that x squared be? On the top or the bottom? On the top, because it's x squared. Do you all agree? So that yellow becomes an x squared. What does the y over y cubed become? So the power on that y is a 1 on top. What's 1 minus 3? It'll be, yes, 1 minus 3 is negative 2, right? So you have y to the negative 2, and because it's negative, we would drop it down. Are you all following me or not? Because I can slow down. This right here is y to the negative 2. This right here is x to the positive 2. So let me try and rewrite that first one here. By the way, what's the 16 divided by 6? How can we reduce that? What goes into both those numbers? 2 goes into both? So it goes into 16 8 times, goes into 6 how many? 3 times. And then you said I was going to have x what? X squared, and we said on top. But the y to the negative 2 would have to come down on the bottom, so it would become a y squared on the bottom. With me on that? Now do the same thing on the other one. What's x over x? What's anything divided by itself? Yes. My 2 on which one? That 2? That's 3 power on x, right? That's a 1. That's like a 3 and a 1. So you go 3 minus 1, and that gives you 2. So just using that property over here, subtract. So in the x's, I do 3 minus 1, which gives me 2. And the y's, I do 1 minus 3. That's different, right? 1 minus 3 is negative 2. So that's why I have a negative 2 on the y. But then I drop it down to make it positive. Drop it down meaning put it to the denominator, which changes the sign of the exponent. Reducing 16 over 6, right? So 2 goes into 16 8 times, 2 goes into 6 3 times. It's not completely correct. I mean, it's not wrong, but it's not simplified. All right, so now what do we have on the next fraction? Let's do the number first. -8 and 6. What number goes into both of these? 2. So how many times does 2 go into -8? -4. And then over on the bottom, 3. How about x over x? They cancel, so it's gone, or it's a 1, right? Anything over itself is 1. But we can say cancel. It's pretty much gone, eliminated. What about y squared over y cubed? It's y to the -1, which means it's going to be on the bottom as a y to the +1, right? I'm not showing these little steps in here because it's stuff that we've done. So that's why I'm not, well, I showed a little bit right here, but I won't show any more. I mean, I'm not showing any more on these two. That all right? At this point, you're done. Box it. Move on. Now, I had a student in my other class ask me a good question. They asked, well, should I try and put these back together? And the answer is no, because if you try, the first thing you'll have to do is get a common denominator. And when you do that, fine, you get a common denominator, you put them back together, and guess where you'll be? Right back here. So you've basically taken the problem, changed it, and then changed it back to where it came from. So you stop as soon as you've reduced each of these expressions. All right, let's look at another one. Where's that homework assignment? How about (18) a to the 5th b to the 4th plus 27 a squared b to the 7th minus 9 ab cubed all over, 18 a to the 5th b to the 7th. I don't know why I'm apologizing. I'm apologizing for McKenna and Kurt because it's their fault. You know what's really sad about spring break now? The people who do go to the beach, you can't go to Mexico anymore. That used to be fun, being able to go to Mexico. Yeah. Depends on what you're there for. If you're there to, like, enjoy the waves, I don't know about that. Okay. This is a pretty nasty looking problem, but I will help you see we have a monomial in the I'm not on meds. It's just amoxicillin. That's all it is. A monomial in the denominator. We have a trinomial in the numerator, right? 3 on top, 1 on bottom. Now, what we can do, because it's monomial, we're happy, right? We're happy to split this into how many fractions? 3. 18 a to the 5th b to the 4th over 18 a to the 5th b to the 7th plus 27 a squared b to the 7th over 18 a to the 5th b to the 7th. Now, I'll show you how this one could work if you didn't want to do the pluses between. You could go minus, but then you have to make sure you put 9a b cubed, and then 18 a to the 5th, b to the 7th. So I'll just, make sure you understand that negative sign there. Why don't you try it? Just real quick, see if you can come up with what each of those three turn out to be. And I'll work through it myself quietly. Yes. Well, I don't know. I mean, you can tell me at the end of the day if you think this one was easier or not. If you have a question, raise your hand. I'd like to come by and help you out. Or if you disagree with my answer, you can raise your hand. I can come by and... Who has it already? Okay. 3 or 4 people. Start the first fraction. Start canceling things out. What about the 18ths? What's 18 divided by 18? 1. So that's pretty much gone. What's a to the 5th over a to the 5th? 1, okay? Now, b to the 4th over b to the 7th, you take 4 and subtract 7. 4 minus 7 is negative 3, right? So this turns into a b to the negative 3. But then you drop it, so it becomes this. So everything else cancels except the b to the negative 3, right? Yeah, you start doing, looking at the powers and subtracting. Yep, that's all you're doing. But you have to do that for each fraction. Anyone else have a question I can come around and help with? You can do it that way also. So if you're kind of mentally looking at that and going, that's b times b times b times b, and on the bottom this b is b times b times b times b times b times b times b, and you're canceling 4 of them up here and 1, 2, 3, 4 of them there, and there's 3 of them left. That's fine. Now, how did I get the second fraction? I looked at 27 and 18 and said, what number goes into both, right? 9. 9 goes into 27 3 times. That's where the 3 came from. 9 goes into 18 twice. What happens to the b to the 7th? They're gone. And then a squared is like having 2 a's on top and 5 on the bottom. 2 of them cancel. You have 3 on the bottom. Or you can say 2 minus 5 is negative 3. A to the negative 3, you drop it down. So that gives you your a cubed on the bottom. Second one, 9 and 18. 9 goes into both of those. 9 goes into 9 one time. That's why I have a 1 on top. 9 goes into 18 twice. Then what about these a's? 1 minus 5 is negative 4. Drop it down, a to the 4th. Okay, b's, you have 3 minus 7 is negative 4. So again, drop it down to the bottom, b to the 4th. Is that okay? All right. So that's your monomial division, dividing a polynomial by a monomial. You split it up, you do each one, you're happy, you move on, right? Box it, go to the next problem. So now we go to the more complicated, more involved type of division. So how about just general poly divided by poly? So what happens if I try and do a polynomial divided by a polynomial? Things do not work out as nice as they just did. So to motivate this, to motivate your thinking on this, I want you to go back to like when you first learned division and what it meant. All right? So check this out. If I put 20 divided by, let's say 6. No, let's not use 6. Let's use 7. At some point in your elementary school, grade school, whatever, you had to do something like what I'm about to do. You would say 20 divided by 7 means I have a division box. I have a 20 inside, and outside I have a 7. Do you remember this? This is like going way back, all right? You ask yourself, right, you say, what do I multiply 7 by to get 20? Well, it doesn't go in evenly, right? If you try 3, it's too big. If you try 2, it's too small. So what you try and do is come up with a number that's big enough without being too big, right? So we would use what here? 2. So I put a 2 up top. Now look, I understand this is going to seem ridiculous right now, but just bear with me. We put the 2 up there, right? Then what did we do? Put a 14 down underneath, right? The way I want you to see that is what you actually did is you took the 2 right here and you multiply times the 7 in front and you put that answer under here. Okay, that's the pattern. You did 2, you did times 7, you put that answer under here as a 14. And then what did you do? You subtracted it, right? Out of nowhere, you come in here and say, take that number and subtract it. So you could, if you want, think of it this way. This was a positive 14, right? We subtracted it, which made it become a negative 14. So we subtract, and now what's 20 minus 14? 6. And then you were supposed to ask yourself, does 7 go into 6? And you say no. And so, I mean, way back, you would say remainder 6, right? Remember that? R6. Do you remember seeing that before? Okay. Okay. Yeah, if you were allowed to go decimals, then you'd have to put a decimal point here and put a 0. But let's say we weren't there yet. This is the way we would do it, right? What we need to do now is also understand what this means. What does 2 remainder 6 mean? What it meant was this: 2 plus the remainder over the divisor. See, 2 is basically what we're saying is if you take 7 and multiply it by 2, you don't get 20. But if you take 7 and you multiply it by 2 plus 6/7, that would give you 20. So where does this 6 come from up here in this fraction? That's your remainder, right? And where does the 7 come from? It's your divisor, 7. So this number is this number, and this number is this number. Okay. What if like the rest of our test was all just that, right? Just give you nice numbers like that? That'd be nice. Now I'm going to refer back to this example here in just a second, all right? I'm going to refer to this. So any questions on this, what we did? Okay. Here's your first example. Now we have division, right? we have a trinomial on top and a binomial on the bottom, not a monomial. So we're all pissed off because if it was a monomial, we just split it up and we'd be happy. But it's a binomial, so we can't do it that way. So we have to use what is called long division. That's what it's called. Long division. Has anyone ever heard of long division before? It just has kind of a bad, they named it, I think they named it wrong because it just gives you a bad taste in your mouth, right? You're just like, long division, seriously? Like long just makes it sound bad, right? It's going to be terrible. It's going to take a while. I'm going to get a headache. All right. But all long division is this. That's what this was long division, okay? But we're going to do long division on this. So watch the way it's going to work. The numerator, which is up top, is like the 20 was, right? And the denominator, x minus 4, is like the 7 in the previous example. So I'm going to draw myself a nice division box. Now, if you're on your paper right now, if you're writing on your paper and you're way down here at the bottom, just start a new page because you're going to need some room for this. All right? So I'm going to do a division like this. Inside the division box, I put the numerator, which in this case was x squared minus 3x minus 4. Now, I have to point something out here. In long division, when you put this in here, it must be in descending order. What was descending order? Highest power of x down. Is that in descending order? Yes. If you don't do it in descending order, things get all messed up. Now, on the outside division box is our divisor. The divisor is x minus 4, right? It's good to also put this in descending order. Okay. Now, before in the previous problem, we said, okay, what do I multiply 7 by to get close to 20 without going over, right? Here, you can't look at this and say, what do I multiply x minus 4 by to make sure it's smaller than x squared minus 3x minus 4? That's a little more complicated, isn't it? I mean, that's a lot more complicated. So we have a systematic way of doing this. Here's what we do. All you look at instead is whatever's out front, the first term of what's out here, and then you look at the first term in here. And you ask yourself, self, how could I turn x into x squared? What do I multiply x by to create x squared? By x, right? So it's kind of like, what did I multiply 7 by to get 20? Well, I could try 2. What do I multiply x by to get x squared? Exactly x. So you're going to take that x and just put it up here somewhere. So that's kind of like the 2 was a second ago, wasn't it? That's kind of like we came up here with the 2. I'm coming up here with an x. Now, what did I do with that 2 after I put it up here? I multiplied it times whatever was out here, and I put that answer underneath. Right? That's exactly what I need to do here now. I need to take this x, I need to multiply it times what's out in front, and bring that answer underneath. So I need to take this x, and then multiply it out here, right? And then put that answer underneath. Now, the way I'm going to do this is because I have to do x times this, I'm going to do it on the side, like scratch work. I need to figure out real quick what's x times x minus 4. Okay, everyone understand that scratch work over here? What's x times x minus 4? What is it? X squared minus 4x. Agreed? Now that needs to go underneath. And we need to line things up here. In other words, if I have x squared, I need to put it underneath the x squared column. We're going to look at this as like a column now. This is where my x squareds go. This is where my x's go. These are where my numbers go. So I'm going to put the x squared underneath the x squared. And where do I put the negative 4x? Underneath the negative 3x. And then what goes underneath the negative 4? Well, nothing, right? I don't have anything else. So some instructors put a 0 here. Some leave it blank. I leave it blank. Is that okay? So what we've done is the equivalent again. All we've done is the step of going 2 times 7 and bringing it underneath. We've x times this, brought it underneath. Now what did we do up there? We subtracted it, didn't we? Didn't we subtract that 14? So I need to come down here to mine, and I need to subtract this. Now what happens if I subtract something? It changes the signs. So this was a positive x squared. It now becomes a negative x squared. And this was a negative 4x. It now becomes a positive 4x. And I like to really over exaggerate the fact that I changed the sign. See how I come in there and I just make them real big and bolded to kind of remind myself I did change the sign from what it was. And now you can add straight down. What's x squared? Take away x squared. It's gone. What's negative 3x? Add 4x. Just an x, right? 1x. And then what's negative 4? Add nothing. Still negative 4. Is that all right? Now, you sure there's no questions?
You're changing the sign because, right there where you exaggerated the
Mm-hmm.
signs or whatever, I understand.
Yep.
Did the minus x squared instead of copying that?
Yes.
But what about the adding sign?
Well, I'm subtracting. When we subtracted 14, we were really saying you're subtracting whatever's down here. So if I say subtract whatever's down here, then everything gets its sign changed. Remember, subtraction changes the sign. So if it was positive, it now subtracts. If it was subtracted, it now becomes plus. Opposite, exactly. Everything's going to switch. All right. What did we do after we got to the 6 here? We said remainder, right? But we did remainder because we said 7 couldn't go into 6, right? Well, we still have to look here. Can we make x become x? So I'm focusing, remember how I said all you have to do is focus on the first piece when you do the division? When we get down to this one, I'm focusing on the first piece again. Can you turn x into x by multiplying it by something? What? 1, right? How do you turn x into x? Multiplying it by 1. So now up top, I need to put plus 1, because that's what I would multiply x by to create x. And then what do you think I'm going to do with this 1? Multiply here again, and then put a new row underneath and repeat the process. LongDivision. LongDivision. So I'm going to multiply over here 1 times x minus 4. What is 1 times x minus 4? Just x minus 4 again? I do this on the side just to keep track of things, okay? Any questions, though, on what I did? So where am I going to put x minus 4? Underneath x minus 4. And then I come through, just like I did earlier, I subtract the row, which means I change its signs. The positive x becomes negative, the negative 4 becomes positive. And they both cancel when you go down. So you have a remainder of 0, which means there is no remainder. Right? You're done because can you turn x into 0? Well, yeah, by multiplying by 0, couldn't you? So you say plus 0, plus 0, but plus 0 doesn't change the problem. So as soon as your remainder is 0, you know you're automatically done here. Or if that remainder was 3, then we would have a remainder of 3. And I'll show you in another problem what happens when we get a remainder. But does everyone understand the process, though? All right. They should call it, instead of long division, they call it fun division, right?
So the answer is 0?
Oh, yeah, no, sorry. No, the answer is not 0. What is the answer? It's up here. Yeah, sorry about that. The answer is x plus 1. Oh, everyone always wants to know how. Okay. Well, it's a great question. Man, I don't want to give you a BS answer here. Um, Hold on, let me answer this question first. I thought I may have said this in the beginning of class. This math that you learn at this level and in college algebra, that's the beginning of math, really, is really just, these are tools, okay? So it's like, imagine, I don't know if you have tools at home, right? You have a screwdriver, you have a hammer. Yeah? You know how to use a screwdriver? You know how to use a hammer? Can you build a house? I mean, but the thing that we're doing here is we're learning the tools. Algebra is the tool. I'm showing you how to use a hammer. You move on, you learn how to use more tools. Then you start getting into higher math classes, and you actually start building things with this. So it's hard at this point in time to show you something really practical that you would be like, oh, sure, yeah, you know. But you have to trust when I say that, you don't put people on the moon, you don't build cars and bridges, and you don't do that without solid mathematical bag of tools and knowing how to use them. That's what engineers have. They have all these tools, they can use them, and they know how to take a problem out of the real world, turn it into a math problem, and that problem may turn out to have this expression in it, and they can manipulate it like we are. And that's kind of like my easy answer for that, you know. What's that? No, it's because it's very difficult. It's very difficult. I've always dealt with this my whole life teaching math. At this level, it's hard to see what do they say? Hard to see the forest through the trees, right? It's hard for me to show you the beauty of math at this point. It's not beautiful here. It's it's just tedious. You know what I'm saying? But once you work with it and you understand it, then you can start doing things with it. So, you can make the argument of, well, why do I need to know this if my major is something else? And it's not my decision. It's the college. Texas says that you need certain courses, right, to get a degree. And math, college algebra, or something equivalent is required. So I think that would be the bigger question. Like if I wanted to do physics or architecture when I was in college, that's what I wanted to do initially. Why did I have to take literature? Why did I have to take government? Why did I have to take art? Or, why? I don't like English. Why do I have to take English if I want to be an architect? I'm not going to write a freaking paper. Yeah, I mean, to me, it's just giving you some sort of broader perspective on things, giving you a general education, a general knowledge. What's that? Yeah, I mean, by getting a general education, you might actually find something that you didn't even know you liked, right? And it may interest you, it may really pull you in. I mean, when we come out of high school, we might be pretty much fixed into one thing we think we like, and then all of a sudden we discover something new. So you never know. Okay, look at this one. Is this a monomial being divided in? No, right? Binomial on the bottom? So we cannot use that quick, just split it all up. So we have to do long division. So when I make my long division here, this is going to suck, man. I need to make sure it's in descending order, right? 27b to the fourth minus 6b cubed plus b squared minus 32b. 9b plus 4 outside. Everyone with me on that? Descending order, we're good? What am I going to look at now? The first terms, right? 9b and 27b to the fourth. How can you turn 9b into 27b to the fourth by multiplying it by something? 3 times 9 is 27, and then how many b's will I need? 4 total, so I'll multiply b by 3 b's, b cubed. B cubed. Not 3b, but b cubed. I know what you mean, but I want to make sure we're all clear with that. So I would need to multiply by 3b cubed. Do you all agree with that? I multiply 3b cubed times 9b, I get 27b to the fourth. Yes. But technically, I'm supposed to take that and multiply it through, right, to both of these, right? To both of them. So I'll do that on the side over here. I'm taking my 3b cubed, I'm multiplying it times 9b plus 4. So you get 27b to the fourth plus 12b cubed. Do y'all agree? And where am I going to put that? Underneath this one. Just lining things up, though. So 27b to the fourth goes underneath. And then I have plus 12b cubed. Come through. And an all-important step here. Subtract, right? Switch the sign. So that's a minus 27. And the plus becomes a minus, doesn't it? So I see how I like totally over-exaggerate that? I do it real thick so it almost wipes out that plus sign completely. Now what? Just add down, right? The b to the fourths cancel, right? That should always happen. Your first step through, that should always happen. You should get those to cancel. What about the next one? 18? Negative 18. B cubed. Then? Yeah, just bring those down. So plus b squared and then minus 32b. All right. Now what? Can you turn 9b into negative 18b cubed? Yes, by multiplying it by what? Negative 2b to the second? Like lined up? You don't have to, but it's actually, some instructors are really anal about that. What's being proposed here is like if I had 3b cubed up here, I should put it on top of this b cubed. And if I have b squared here, it should be on top of this. It actually doesn't matter. You don't have to have it. That's like being really organized with your stuff there. Okay, what now? I'm going to come over to the side and do some scratch work. I'm going to do negative 2 b squared, and I'm going to multiply it times the 9b plus 4. That gives me my negative 18b cubed, and then I get, what, minus 8b squared. And that will go underneath. So negative 18b cubed minus 8b squared. And I have my subtraction, and then I need to come in and change the signs again, right? This one is starting to feel like long division. Adding straight down, the first terms cancel. What about the second terms? We have 8b squared and b squared added together gives you 9b squared, right? And then I bring down the negative 32b. We're going to have to do it 2 more times, just so you know here. It's going to go twice more. How do you turn 9b into 9b squared? All you're missing is a what? A b. So I need to multiply by b. Are y'all getting this, or? I mean, it's just this repetitive thing until we get to a place where we can't go any further. So I think I'll do this one mentally. B times what's out here, right? That's, what's b times 9b? 9b squared. And then what's b times 4? 4b, so plus 4b. Yeah, you don't have to write these out. Okay, if you can do them in your head, that's fine. Then I subtract, change the signs. First terms cancel, negative 36b. Now, how do you turn 9b into negative 36b? Times negative 4? I'll do this one in my head also. Negative 4 times 9b is negative 36b. And then negative 4 times positive 4 gives me negative 16. And it's getting so much, I'm going to have to zoom out so I can get it all on one page here. Come through, change the signs, and add down. What do you have? 16. Now, the reason we're done now, at least with this part of it, is that I cannot turn 9b into 16 because 16 doesn't have a b in it. So I'm done. But that's our remainder, right? So if I go back up to the top, I could put R6 next to that. R6 remainder. But that's not the way we write the answer. 16, yes, thank you, 16. So I'm going to put the answer down here. The final answer is 3b cubed, help me out, plus minus 2b squared, plus b, minus 4, and then remainder, right? So we do, this is what you do for remainder, I'll put it in red, plus the remainder, which was 16, over the divisor, 9b plus 4. Remainder over divisor. Okay. So I'll answer your question with a more specific example, when you would ever use this. I'll tell you when an engineer would ever use this. An engineer might be trying to compute the total work done by some object applying a force on something. Okay, so I'm sitting here and I'm carrying this around. I'm trying to figure out, how much I just cost myself by dropping. I'm trying to carry this, right? I am doing work. All right. So engineers to do work, they take a function and they do something called integration to it, and they can compute the work. And in my Cal 2 classes, there are many problems that we run into where we have to use, we work with a function like this. These are called rational functions, polynomial divided by polynomial. And that's a very ugly thing to look at. So what we do is we put long division on it, and we get it down to this. And this is just, look at these first, isn't that much cleaner? Those first ones, aren't those cleaner than that thing up there? And so in calculus, it's very easy to work with these. And it turns out that that's actually easy to work with too. So it's just an intermediate step in a larger problem usually, but it's something you can't do unless you know how to do it, right? It's like, okay, there's a polynomial divided by a polynomial. How do I simplify that? Long division. Do it, and now continue the problem. So, well, that was exciting. There's still something else you need to see. So this will probably be our last example because it's already almost 1:30. So check this one out. 2x cubed minus x plus 1 divided by x plus 7. All right, we do not have a monomial in the bottom. Oh, you know what? Let's make this a little more exciting. Take that x in the bottom, make it x squared. Change that 7 to a 7x, and let's just say minus 2 out the back. I haven't given you where we're trying to divide by a trinomial, right? All right, so we need long division. I need to put my numerator underneath this division box. It's not really a box, right? But that's what we'll call it, division box. It needs to be in descending order, which it kind of is. But notice there's something about the numerator that's kind of interesting. It doesn't have an x squared, does it? But in long division, you must always account for any missing terms. So I need to account for the missing x squared. So what I can do is I can put a 0x squared, then minus x plus 1. Does everyone see what I've done here? I put a 0x squared right in here because there was no x squared up here on the top, but I put it in here. Now, why in the hell would I do something like that? Just to make your life worse, right? Just confuse you more? Well, the reason why is because, you know, when we start doing the multiplication, we start figuring out what we need, and we come over here and we figure out everything, and then we multiply through and we put it underneath, right, to subtract. What if in that step I get an x squared? Where would you put it? If you don't write that x squared in there, you're not going to have a space to put it in. That's what's going to happen on this problem. We'll see. Let's just work through one cycle of this and see what happens. But make sure you put that 0x squared in there. And then on the outside, do your x squared plus 7x minus 2. And then I look at the leading terms, x squared and 2x cubed. What do you multiply x squared by to turn it into 2x cubed? 2x. I'll do that multiplication on the side as scratch work. I'm doing 2x. I'm multiplying it times x squared plus 7x minus 2. What do you get there? Two x cubed. Good. Okay. Put that underneath. So I go 2x cubed underneath 2x cubed. And do you see what I mean now? I have a 14x squared. if you had not put this space in here, right? If you had not put that space in there, here's what it would have looked like. You would have had this, right? And now where do I put the 14x squared? Yeah, I mean, but that's why I'm saying if you don't put that in there, I just switched it back. If you hadn't put it, then you're like, where are you trying to cram it in here? It doesn't fit anywhere, right? So that's why we like the convention is to add a 0x squared minus x plus 1. So now come in here, do our plus 14x squared, then minus 4x. Come through and change signs. Minus, minus, plus. What do I get when I add down? Negative 14 x squared plus 3x plus 1. Are we done? No, because you can turn x squared into negative 14x squared by multiplying by what? Negative 14, right? So I'll do that on the side again. I'm doing negative 14 times x squared plus 7x minus 2, which is negative 14x squared. Uh-oh. What's negative 14 times 7? 108, negative 108 x, and then negative 14 times negative 2 is positive 28. But again, the pattern, do you see the cycle of what we keep doing here? What's wrong? Is 98? What was it, 7? Oh, it's 70 plus 28. I don't know why I did 80 plus 28. Thank you. 98, not 108. Well, I was going to take attendance off of the quizzes, but since not everyone has them, I will pass it around today. Make sure I've got the right one here. Yeah, please sign in. All right, put that underneath. Negative 14x squared minus 98x plus 28. And then come through and change the signs, right? What do you get if you add straight down there? (101x minus 27). Okay, I think you can get that going around. 101x minus 27. I agree. 101x minus 27. Okay, now let's ask ourselves this question. Can you turn x squared into 101x? No, because now isn't x a lower power than x squared? So you can't turn the x squared down, make it go down into an x, right? By multiplying it by something. Y'all follow what I'm saying or not? So we are done, and this is our remainder. The whole thing is our remainder. So our final answer here is what? 2x minus 14 plus 101x minus 20. So the remainder over the divisor. X squared plus 7x minus 2. Yes, I'll just zoom out a little bit. Questions? What do y'all think about this? You got to practice these, right? You don't want to walk in here next Thursday and the problems I ask you on the test be the first ones you've really tried. You know, you got to do your homework on these, or else it'll catch you. Because you got to get good at not messing up the signs and little things here and there. All right, here's your homework assignment. Page 384, numbers 9 and 17. Numbers 9 and 17 are monomial division. So those are the nice ones. And then 21, 25, 41, 37, 51 are all long division problems. 51 is a bit of a challenge. Let's see how you do with that. It's just long, kind of like the one we just did. Let's see. We've got about, 13 minutes left? No, not 13 minutes. Sorry. 7 minutes, right? 8 minutes. I don't think that's really, it's not enough time to start a new problem. Not enough time for me to give you a quiz. Is the sign-in sheet all the way around yet? I guess in that case, we'll just have to end class. If you want your assignment back that you gave me today, if you want it back, just hang out and we'll get it back to you right now. I just need to take a grade for it real quick. Just check your email, or you can write it down right here. It's not every problem, so it's that right there. It's right there. Everyone have a great day. I'll see you. Is that from? Okay, just right there is fine. Yeah, you can get it next time if you want. Yeah, it's just some people gave me their binders and stuff, so they want it back.